worth it.
All right, so we're talking about the three theorems today. Do you remember intermediate?
Yeah.
Hardly. What do you mean hardly?
I told you, once we learn a unit, we don't remember it.
Well, that's going to be tough when I start retesting some stuff. Okay, so intermediate value theorem, it has to be continuous, right? Because we learned it in the continuity interval, right? And then you prove that you get a y value, and then you get another y value, and if it has a lower y value and a higher y value, you can prove that it will go through somewhere in between. Do you remember that?
Yeah.
Yeah?
Yeah.
Like seriously, do you remember?
No, I actually do, yeah.
Okay. Okay. All right. Okay, this is to prove that like the y value equals something. Now we can prove that the slope will equal something by mean value theorem. We'll start with mean value theorem. So what mean value theorem says is it's got to be differentiable. Differentiable also implies
Continuous.
yeah.
Okay, beast.
Okay, so it's got to be differentiable and continuous. And what it says is if you take 2 points and you find the slope between the 2 points, that's called the secant line, right?
Yeah.
Secant is also average rate of change, yes?
Mm-hmm.
Then what you can prove is that if your average rate of change is a certain value, then you'll have some point in between A and B where your derivative or your instantaneous rate of change will be parallel to your average rate of change. So they'll be equal. So you can prove that tangent or instantaneous rate of change will be parallel to your average rate of change. A lot of people remember this as, come on, AB kids. A-rock
Average rate of change.
Oh, yeah.
equals I-rock.
What does I-rock mean?
Instantaneous rate of change.
Okay.
So average rate of change is f of b minus f of a over b minus a. And instantaneous rate of change is f prime at some c value. And what it says is they're going to equal where c is inside of the interval a to b. Actually, parentheses. Not at a and not at b, but somewhere inside a and b. Is a mean value theorem. Real life example of this is, do you know when you'd go on like Easy Pass,
Yeah.
right? And then you enter a toll on Easy Pass, and then you exit another toll on Easy Pass, and they charge you like $4, but that's not part of mean value theorem. Anyways, they like time when you enter the Easy Pass, and they time when you exit the next toll, and they have your distance so they can find your average speed, right? Yeah.
Yeah.
And because if you know the distance, the time you started and the time you ended and the total distance you traveled, you can find average speed.
But why do they care?
Yeah, why
Because
do
if your average speed is higher than the speed
Will they ticket
limit,
you?
then they can send you a ticket.
Really?
Yeah.
Zero. No.
That's not good.
Huh? What? Yeah.
That's not good at all.
So
That's why.
they don't do it anymore because
Oh,
like somebody like took them to court and was like, you can't prove it, although you actually can prove it. It's like mean value theorem, but but they took them to court and they're like, no, you can't do that. That's unconstitutional. So they don't do it anymore. But they used to mail you tickets, like if your speed was higher.
That's only if you take the time.
So a lot of people, like would if you go on the New Jersey Turnpike, like up to like New York or something, a lot of people would enter the toll and then drive past the speed limit, but then like stop at a McDonald's for like 30 minutes to accumulate more time and then go back out so that your average speed was slower. I never did that. I don't know what you're talking about, but like I'm just saying, I've heard that people have done that before.
Mr. Moy definitely done that.
I don't speed. I'm good.
I've seen that. Subaru.
No. I
My
feel like
Subaru?
this was
I've seen that Subaru
driving
speed
like
down.
10 above, like. I feel like that's you.
10 above?
50 above.
Only 10?
No.
Over the roundabout.
What are, I don't understand these roundabouts, by the way. Are you supposed to stop for the next person?
No.
You just keep going?
You just stay in there.
No, I don't get them either. You have to like wait for people to come in.
Wait, is all this dialogue on this?
Yeah.
Inside.
Oh, okay.
There was dialogue in the last video.
Oh, I thought when you said inside the circle, I thought like it was like car right here. And I was like, why would there ever be a car inside the circle? That's me. That's my car. That's why I have a Subaru. Because when I test drove it, the guy drove onto a curve and was like, look what I could do. And I was like, that's so cool, I need to do that. So I bought it.
They let you go.
My car's license plate is Subaru. I know. But the S is a 5. And it pisses me off because I need to find the person that has the actual S and steal it from them.
Yeah.
Okay. All right, but it's got to be, so it's got to be
No, I just skip until something is like written down.
continuous and differentiable, because if you have a graph that looks like, I don't know.
This is the best one ever. Distracted.
Like, if you have a graph like this, if I drew 2 points and I made a secant slope,
Yeah.
is there any point on the red graph where my slope looks like that? No, right?
You're right. You're what?
So that's why it's only true for
It's not.
continuous functions. And then, if I have a point like this, and a point like this, and my graph looks like this, and I drew a secant line between these 2 points, there's no point on this graph where the slope will be parallel to this. So that's why it has to be differentiable. Do you see? Okay, whatever. Let's keep going.
Yo, go back to that. I got your own.
Yo,
Thank you.
okay. You don't see it? Can you draw on this red graph a slope that's parallel to this purple
Yeah.
one? What?
Yeah?
Where?
I don't know. Oh, I guess you can.
Right. That's the point.
Okay, wait, and then you can't draw something that one either.
You can't draw a parallel slope to this one either, and that's because it's not differentiable.
Okay.
But if it was differentiable and continuous, then you would be able to draw a point on your curve where they will be parallel.
Okay.
Sometimes you'll have 2 points, but it only guarantees that there's one.
Okay.
Okay. Verify that mean value theorem holds for f of x on the interval 1 to 3. So I only have to verify that mean value theorem exists on this one. So what does it have to be? First? Well, yeah. Let's start with the first level of differentiability. Is it continuous?
Yeah.
Yeah. So this is continuous. And then let's take the derivative. F prime of x equals negative 2x plus 6. Is the derivative, does the derivative exist on the interval 1 to 3?
Yeah.
Yeah.
Yes, so this is differentiable. If you're doing free response, you want to say both, and you can abbreviate. You can just say like cont check diff check. Okay. And then we find our average rate of change, AROC. That's f of 3 minus f of 1 over 3 minus 1. And we get 3, 9, 3, right? And then 1 in here. is 1. So minus -1
Plus.
over 2. 2. Okay, so there exists, so if you were going to do free response, you would say f of x is continuous and differentiable, and then you would say by mean value theorem there exists a c on the interval 1 to 3 where the derivative at c equals what number? 2, because that's what my average rate of change slope is. All right. And then if it asks you to find the value, then you set the derivative equal to 2 and you find where it happens. But this one doesn't say find the value, so we won't do it. Do you get it? Okay, cool. 4 problems. Let's do mean value theorem for these 4. Okay, so number uno, is it continuous on the interval 0 to 32? Yeah or no? Yeah. Continuous, check. Let's take the derivative. 2/5 x to the negative 33/5. Okay, so that's 2 over 5x to the 3/5. Now, for differentiability, it's got to be continuous on the interval 0 to 32, but it's closed bracket. But it's only got to be differentiable at the open interval 0 to 32, because remember, if it's endpoints, then it doesn't have to be differentiable at the endpoints. Okay, so is it differentiable on the open interval 0 to 32?
Yeah.
Yes, okay, check. All right, now you would say, let's find our slope. So 32 to the 2/5 minus 0 to the 2/5 over 32 minus 0 is
That's fine.
4 over 32, 1 over 8. Okay. And then if you wanted to say your little statement, let's just do it for this one. We would say by MVT there exists. Did I do too many eyes?
Yeah.
Yeah. Exists a value. Oh, you don't have to say a value. C on the interval 0 to 32, where f prime of c equals what value? 1/8. Okay. And then this one says find the number that it happens at. So we'll set this 2 over 5 c to the 3/5 equal to 1/8. And we'll solve. 16 equals 5c to the 3/5. Yuck. C equals 16/5 to the 5/3. That's gross. But that's the number that it happens at. Okay. Am I going too fast?
Should I?
No? Where's your book?
It's in my bag.
When you're not even taking notes.
No, I know. I'm gonna watch the video later.
What video?
This video.
Why don't you do it right now?
Because I have something to do next class.
Well, why didn't you do it earlier?
What was it?
Because
I know, this is a little video.
Trick or
There's
treating.
no trick or treating because I'm not 12.
What happened?
Okay, is this one continuous?
Yeah. Who?
This boy, you really just called me
Is this
out.
one continuous?
No.
Like the one person that's gonna watch the video.
I'm gonna watch the video.
No, there's 4 people not here. John
Yeah.
Michael will.
Oh.
Yeah.
Oh no.
Oh,
like,
and
when
name all
people-
of
Timmy
them.
will.
Available.
Yeah.
Hi,
My
Timmy.
teacher said
Sarah
he
will.
brings it.
And
Wow. This fun.
Just say hi to them.
yeah, hi guys.
It's auto A.
It's not auto.
So it's not continuous at x equals 2, so mean value theorem doesn't. I can't spell. D-O-E-S-N apostrophe T. Apply. Okay, cool.
So if it's not continuous, we don't have to do it.
We can't even do it, yeah. On the interval. If it's continuous on the interval, then you're okay. So like if it was like 3 to 5, then we could do mean value theorem. All right, number 3. Continuous? From 1 to 3? Yes.
Straight. Much photos free.
Take the
Is that the
derivative.
Is that the one you read something?
No, they haven't put that one in. I don't think they're gonna. It's gonna be in the yearbook.
Can you stop talking? Is that differentiable on 1 to 3? Yes. Differentiable. And then we do 3 3 1/3 minus 2 over 3 minus 1. Or 10 thirds minus 6 thirds is 4 thirds over 2 is 2 thirds. Okay. So you would do this whole statement again, but we're not going to do it. We're just going to solve the problem. So we set the derivative 1 minus 1 over x squared equal to 2 thirds. So 1 over x squared equals 1/3. And so x has got to equal root 3, not the negative. Why? The interval is 1 to 3, and negative root 3 is not in there, so we don't care about it. Okay, number 4, continuous?
Yes.
Yes. Derivative, y equals 1 over 2 square root x plus 2 over 3 x minus 2 to the 2 thirds. If you do the negative sich correctly. All right. On the interval 1 to 9, differentiable? What? Look at it again.
Oh wait, no, never mind. Doesn't-
Where? Not
2.
differentiable at x equals 2, because that's where your denominator is 0. So MVT doesn't apply. Hey, thanks. Thank you. You. It's just your counselor.
Oh, okay.
It's not a bad thing.
Sit right now.
No, it's at the end of class.
Rip.
Okay. All right. This guy Rolls just schemed off of mean value. There's no guy that actually is named mean value, but Rolls schemed off of the person that made mean value theorem, because it actually came after mean value theorem, and he just made his own theorem and named it Rolle's theorem. So Rolle's theorem says that if your point at A and your point at B are the same, then your derivative will equal 0 at some point on the interval. But that makes sense, right? Because what's the slope of your secant line? 0, right? And if at some point your, like by mean value theorem, if your instantaneous rate of change equals your average rate of change, if your average rate of change is 0, then your instantaneous rate of change will also be 0. So Rolle's is the same as mean value, but it just tells you that your secant slope is 0. So he made his own. So I'm going to make Moy's theorem. And I'm going to say if your secant slope is 2, then there exists at least one number c on the interval a to b where the derivative equals 2.
That's so boring.
Let's start it. Create a movement, guys.
Can we write that on the AP exam?
Yeah, math movement. But if you do it on the AP exam, just write MVT. So for Moy value theorem. I think that would be good. Let's do it. Okay, you do not have to use or say Rolle's theorem. Like if you want to boycott Rolle's theorem, you can just say by MVT if you want to. But if you want to accept Rolle's into your heart, then you can say by Rolle's theorem. Anyways, let's do this. You still have to be continuous. Is it continuous?
Yeah.
How about the second? Derivative
Yes.
is 2x. It's differentiable. Check. Okay. Now we just find f of 3. F of 3 is 18, and f of negative 3 is 18. So if I do 18 minus 18, I would get 0, right? So these two are the same, and if they're the same, then the derivative 2x has to equal 0, or you could do 2c if you want to, if you're solving for the c value in between. So c's got to be 0. All right, let's do number 2. Continuous, yes. Differentiable, let's find it. But I mean, all polynomials are differentiable. Differentiable. Check. F of 2. 2 cubed. 8 minus 8 minus 2 plus 2. That's 0. F of negative 1. Negative 1 minus 2 plus 1 plus 2. 0. Same. So same, we set the derivative equal to 0. 3c squared minus 4c minus 1 equals 0. And then we solve. But I don't think I can factor it. Can I? No, I cannot factor it. So what do we do?
Quadratic formula.
Yeah. C equals negative b plus or minus square root b squared
Why can't you
minus.
bring the 1 to the right and take
Yeah,
out a c?
completely square.
Yeah, you can. All over 2a. This is easier. You will have to use completing the square later. But not now. Okay, 3?
You don't have to simplify that?
Nope.
Okay, awesome.
Continuous?
Yes.
No.
Oh no.
You fell right into my trap. Not. Continuous at x equals 0. Rolle's. Doesn't apply. Okay. And number 4, this will be the last one we do today, and then I'm going to save this last one for the warm-up before your standard that you'll take next Friday on this, because you're going to take the test next class, and then we'll use this as like a refresher
Won't that be
for
like
the next Friday.
2 Mondays?
Yeah,
Why?
because we only have class on Thursday.
Oh, yes.
Oh,
Fair.
yeah, next Monday. So we'll need it. We'll need it for a review. Okay, this one's continuous. Checkies. Derivative of sine is cosine. Differentiable, yes. F of 0 is sine of 0. 0. F of pi, sine of pi is 0. Samesies. Oh, I wrote samesies. Whatever. I'm gonna keep going with it. Okay, then if they're samesies, we said cosine. I guess we'll use C equal to 0, and then when is cosine 0? At over 2. Yeah, but 3 pi over 2 is not on our interval.
Oh.
But we'll just choose pi over 2. Okay? Cool? All right, finito. We're done for today, and then you have 30 minutes to decompress. Have a zen, right?
Moy, do you ever let your 6th period out like early? If you guys finish early?